Hi, so the objectives for this video include degrees, minutes, and seconds, betweenness and collinearity, perpendicular lines, right-angle triangles, midpoints and segment trisectors, and lastly, angle bisectors and trisectors. The major angle measure conversions that we must remember are that 1 degree is 60 minutes, 1 minute equals 60 seconds, and lastly, 1 degree equals 3,600 seconds. So, in the first problem, they ask us to convert 87.5 degrees into degrees and minutes. 87 degrees will remain 87 degrees, and the half degree will be multiplied with 60 in order to get 30 minutes. We multiply by 60 because 1 degree is 60 minutes. So our answer would be 87 degrees in 30 minutes. The second question here asks us to convert 60.4 degrees to degrees and minutes. 60 degree will remain 60 degrees, and 0.4 can be rewritten as 40 by 100. We multiply it by 60. All the zeros cancel out, so 4 times 6 is 24. So we have 60 degrees and 24 minutes. Now, moving on to the next question. It asks us to convert 71.54 degrees to minutes, degrees, and seconds. 71 degrees will remain 71 degrees. 0.54 degree can be rewritten as 54 by 100. We multiply it by 60 in order to obtain the minutes, so we have 32.4 minutes. Now, 32 minutes will remain 32 minutes, but the 0.4 minutes can be further converted into seconds. 0.4 is rewritten as 40 by 100. 40 by 100 times 60 results in 24 seconds. So 71.54 degrees is 71 degrees, 32 minutes, and 24 seconds. The next topic we're going to discuss is collinearity. Collinear points are points that lie on the same line. Non-collinear points are points that do not lie on the same line. As you can see, we have a figure of a triangle MRT. MOR are points that lie on the same line and therefore they're collinear. MPT are also points that lie on the same line and are collinear. OXP and RST are two other sets of points that lie on the same line. However, we cannot conclude that MPX are collinear. Similarly, we cannot conclude that MRS are collinear because they do not lie on the same line. Moving on, we're going to discuss the betweenness of points. In order for us to find and conclude that a point is between two other points, we must be able to identify them as collinear. Here we have segment CB, and we know that point G is between point C and B because they're collinear. However, we cannot conclude that point Q is between point P and R because they're not collinear. Midpoints or bisector segments. A point, line, ray, or segment that divides a segment into two congruent segments is called the midpoint of the segment. Notice how I have only mentioned segments being divided and not rays or lines? This is because lines or rays go on forever on both sides and therefore have varying midpoints that can't be determined. Now, in reference to the diagram drawn to the right, we have two segments, segment AB and segment PR. The both of them seem to have a midpoint, but we cannot conclude or assume for certain that point G is the midpoint of segment AB. But we can assume point X is the midpoint of segment PR because the diagram shows that segment PX is congruent to segment XR. Trisection points or trisecting segments. 2 points, lines, rays, or segments that divide a segment into 3 congruent segments are called the trisection points of the segment. In reference to the diagram drawn to the right, we have a segment AB, with trisection points G and Z. Angle bisectors and trisectors are similar to segment bisectors and trisectors, except for the fact that they are responsible for dividing angles. A ray that divides an angle into 2 congruent angles are called angle bisectors. So angle AGB has angle bisector ray AZ. Angle trisectors are rays that divide angles into 3 congruent angles. So angle PQR has ray QS and QT as their trisectors. Lines, rays, or segments that intersect to form right angles are called perpendicular lines. We have line AB and line CD that intersect to form a right angle. We have line segment UV and XY that intersect to form right angles, and we have rays ST and QP that intersect to form right angles. A perpendicular symbol is an upside down T. Perpendicular right angle triangles. Triangles with one right angle is called a right angle triangle. Here we have a diagram of triangle ABC with right angle B. The segment opposite to the right angle is called a hypotenuse. We have segment AC as the hypotenuse and segment AB and BC as the legs. We have two theorems that relate to the topics that we have learned today. The first theorem is that if two angles are right angles, then they're congruent, and if two angles are straight angles, then they're congruent.